Okay, welcome everyone to Nature Knowledge. I'm Dr. Shelly Johnson. I'm State Specialized Agent with IFAS Extension, and I'm the host of this speaker series. Thank you all for being here today, and just a few things to go over before we begin. I see a lot of guesses in the chat about our little fun quiz question at the beginning. Wow, we've got ranging from like 5 to 200. Yeah, so it was kind of hard to word the question. So compared to and this data, I guess, came from the impact map. So compared to the time frame between 1980 to 2010, how many more days per year on average will be above 95 in the next 20 years? So on average, between 1980 and 2010, there were 7 days above 95 degrees each year. And it's predicted from the impact map between 2020 and 2040 timeframe that on average each year, there'll be 26 days of over 95 degrees Fahrenheit in Florida. So the difference was 19. But yeah, so a little bit of interesting little tidbit there for you. So also, if you have other suggestions for future programs, future topics that you would like to learn more about, other issues that you think would be a good topic for this program, please go ahead and also put that in the chat and let me know. I'm always looking for new topics. And we are recording this program, and all of the recordings that from past programs as well as future programs, including this one, are all posted online on the IFAS blog. And the link for that is in the email confirmation that you did just receive with the link for the program today. Also, this is being live streamed on one of our partner programs Facebook page, and it will also be available. The video will be available there as well if you want to watch it on Facebook. For our topic for today, this is a very important and timely topic, and hurricane season officially begins on June 1st. So today I thought it would be very appropriate to discuss this topic regarding climate change and how it's affecting summer weather and hurricane season in Florida. So with us today, I'm really pleased to have Libby Carnahan. She's with IFAS Extension. She is an agent with Pinellas County and also Florida Sea Grant and a climate change professional. In her job, she develops marine education programs focused on issues that impact marine and coastal areas. And she also works closely with community leaders and decision makers on coastal sustainability and resilient community planning and development. So I am pleased to have her today to share some information about this topic. And with that, Libby, I'm going to go ahead and stop sharing, and you can go ahead and pull your slides up.
Well, thank you, Shelly, very much for inviting me. Just let me know if I need to adjust anything. So today I'm going to talk to you about climate change and impacts on our hurricane season. I'm going to touch a little bit on some of the summer weather, but really the hurricanes are kind of such a full topic that I've mostly stuck with that. And I already saw other climate change topics come up in the chat box. And so, you know, I can work with Shelly and our climate work action group at Florida Sea Grant on developing future webinars. Okay, all good? All right. So as I was refreshing my presentation, sitting here at the computer, I get a phone alert for a headline. And it's that NOAA predicts the 6th consecutive above average hurricane season. So we cannot be more relevant than we are, folks. We're cutting edge, on top of the headlines. This is what they're predicting for this year. 13 to 20 named storms, The average is about 14, 6 to 10 hurricanes, and 3 to 5 major hurricanes. So that's why we're having this conversation. Okay, now I'm gonna try and let me see. I think I will save this for the end if we want to, but you can look back to, because I couldn't get a hyperlink on this. So you can go to the NOAA Hurricane Center and you can get really good, good stats, good imagery, good everything on all the past hurricanes and tropical storms. They're all archived on their website. What I think is really interesting to watch is the movement of the cones as the predictions change over time. So actually, let me see really quick. I'm going to attempt fate and try and share share my website if I can find it really quick. And show all windows. It's not even. No, it's not jumping up at me, so I'm gonna skip that one. But it does show a change over time. So with Hurricane Irma, you might recall that as that storm moves from that position towards the west into the Caribbean, at one point, pretty much the entire state of Florida was in what we refer to as the cone of uncertainty. And at that time, the hurricane was a lot closer. So we were pretty much the entire state was on watch. A lot of people were evacuating out of state. We learned a lot, I think, about how far we need to evacuate, but also there was, a lot of concern. And then with storms in the past, Hurricane Charlie back in 2005, I think, that one, came across the state and hit Orlando really hard, and that area was without power for more than a week. So folks were really afraid to stay in the state at that point. So we can say that within the past few years, everyone in Florida has to some degree prepared or responded, at least been in the threat of a hurricane. So I want to share, I did use references for this presentation. I went to some of the best. So David Zierden is our Florida state climatologist. Each state does have a climatologist, and he is situated at Florida State University in the Center for Ocean and Atmospheric Prediction Studies. He gave me some of his recommendations and talking points and referred me to his colleague, Dr. Allison Wing, who is in the Earth, Ocean, and Atmospheric Sciences Department of Florida State University. And she's written blogs on the subject, and a lot of this kind of comes directly from her messaging. She's done a great job working to make things very understandable for the general public. I'll say I don't go into too much technicality, but I can put you in directions at the end if you want to take deeper dives into atmospheric sciences. Knowing where to get your information is very important. So what I consider my primary source for climate change information is the National Climate Assessment. It's mandated by the Global Change Research Act that a comprehensive report is written for climate change, for Congress and the President of the United States every 4 or 5 years. This was initiated under George W. Bush and then put into act under Bill Clinton. So this had bipartisan support. This was our 4th National Climate Assessment that was published in 2018. It's written in, there's different regional chapters. There's 10 regional chapters. And let me see if I'm gonna remember how many sector, I believe 16, 16 topic chapters. So these are just some of those written, but things focusing on agriculture, water, economy, oceans and coasts, tourism, indigenous peoples, ecosystems. All of these areas are have their own focus, and generally they're informed by a larger report that is written to inform the National Climate Assessment. And that's usually a multi-agency initiative with different federal agencies like the EPA, health associations, NOAA, National Oceanic and Atmospheric Administration, and so on. So we know that, so this is the comprehensive report on climate change. And here's just a look at what impacts we can expect from climate change. And I'm gonna go through my climate change slides, but try and go through fairly quickly and succinctly on our way to the hurricane conversation. So as you can see here, we do expect a lot of impacts from climate change, and weather is certainly one of them. I saw a lot of you in the chat start to touch on questions about saltwater intrusion, water resources, water quality issues. All of these things are very important, and it's hard to decipher the signal of climate change oftentimes from the signal of human influence, you know, certainly in some of these areas, but it's easier in terms of hurricanes, or somewhat. We'll see. So here's a little bit of my involvement in climate professional associations and communities of practice around the country. I realize I forgot one that I'll share, but I did in 2018 go through the Association of Climate Change Officers, 2019, Climate Change Professional Credentialing. And so that is a credential that I carry now, and it's getting more widespread. Not a lot of people obtaining it yet, but folks that work at the planning level, in stormwater, some resiliency and sustainability directors at cities and counties are also seeking this credential. I've been active since 2011 in the Gulf of Mexico Climate and Resilience Community of Practice. So I think I really mostly missed off the kickoff year, 2010, before I was with Sea Grant. But that is a network of the 5 Gulf states sharing best practices for communication and science related to climate change and sea level rise adaptation and planning. Also part of the NOAA Sea Grant Climate Network, and what I forgot there was the Florida Sea Grant Climate Work Action Group that some of my colleagues are very active on and producing great resources these days for municipalities as well as individuals, schools, you name it. So if you have a need for climate change information, please contact me and we can get working with the Work Action Group and figure out how we might best be able to serve your needs. The National Adaptation Forum is a conference that's generally held every 2 years that shares best practices for adapting and mitigating for climate change and sea level rise, and that will be held in the spring of 2022 in Atlanta, rescheduled from this year. And then at our local level, our Regional Resiliency Coalition was formed under the Tampa Bay Regional Planning Council in 2018 and signed by elected officials. So a little bit of an overview of climate change now. So as we know, weather and climate, not the same thing. So weather is short term, it's in a limited area, it's what's happening outside your window right now, it's whether it's sunny, cold, windy, that day or the next few days. Climate is long-term, wider area, wider ranging, looking at seasonal changes. That question that Shelly put in before we got started was a great example of how folks look at climate. They usually look at like a 30-year average. So I can't remember, I think she had say 1980 to 2010. The average of that would be the climate for that period of time. To compare that to now, they would probably take the period of 1990 to 2020, another 30-year segment. So they're not comparing year to year, they're looking for larger scale changes over larger geographic areas. These are some of your factors that can affect climate change. So you can see there's a lot involved. I am glad that there's climate scientists of all sorts of varieties working at our universities across the United States and the world. So what does the science say about climate change? I'll go through pretty quickly. So the carbon cycle has been very long understood. We know that animals respire and give off carbon dioxide, and that plants require carbon dioxide to respire, and then they give off oxygen. And as plants and animals die over time, they decay, and then that carbon becomes trapped deep under the Earth's surface, and it has been figured out how to get that carbon out of the center of, or not the center of the Earth, but out of underneath the Earth's surface and burn it. And that created the Industrial Revolution, and we're able to drive cars and fly planes and get places faster and use our technology. And certainly no one would want to go back in time, but we have certainly stressed out our planet. So just as a reminder, the CO2 and these other greenhouse gases are what makes our planet inhabitable. The fact that we have these trapped in our atmosphere allows us to capture some of the sun's energy and have this temperature that is conducive to human, plant, and animal life. So if we did not have these gases, the Earth's temperature would be about 0 degrees Fahrenheit. So as I often say, not a temperature that Floridians really want to see full time. So how do we track climate change? Well, back in 1948, a researcher Keeling began recording carbon dioxide concentrations at Mauna Loa Observatory in Hawaii. What he first noticed was this intra-annual variability based on the growing seasons. That gave him enough interest to continue to get grant funded and collect more data. And what we've seen is this slowly but persistently increasing carbon dioxide concentration in our atmosphere. And so this is very concerning. We've seen it go from under 320 at the beginning of being recorded to nearing 420 these days. And so lots of folks will chime in and say, well, hasn't the carbon dioxide in the atmosphere always been changing? And I will say this, this graphic is based on, this small amount here at the end, at the right-hand side of the graph. I'm not sure if you guys see my cursor when I move it. I want to go over here. Can you see that cursor, Shelly? Thumbs up or no thumbs up?
Yes.
So you can? Okay. So here we're looking at amount of actual recorded data. So that would be data like at Mauna Loa in Hawaii. But before this point in time, what they do is they create kind of a proxy record, or they're reconstructing what they think the atmosphere was like during those years based on information from ice cores, from foraminifera and other shells, where they recreate the carbon isotope atmosphere, and then can learn pretty much the atmospheric characteristics of the time. So it's slightly, it's slightly less certain science just because it's not direct measurements, but the science is still very strong. And what we see here is that we have not seen a carbon dioxide increase like this in the past 420,000 years. So it is starting to sound certainly like humans are contributing to increased carbon dioxide concentrations in our atmosphere. So here's a graphic from the Environmental Protection Agency looking at greenhouse gas emissions in the United States. And this is a great graphic. Folks have really liked looking at it. It's visual, it's simple. There's a lot of information packed in here, but it's very understandable and easy to see. We can see what industries are emitting most of the carbon dioxide. Don't look at the 5% residential and pat ourselves on the back yet, because we still participate in every sector pretty much in this graphic. And this is how we behave as a country right now. And so we know that as a country and as a planet, we need to increase carbon dioxide emissions if we are going to try to, well, that's what I'm gonna, here, spoiler, increased CO2 causes increased temperatures. So as we talked about the greenhouse effect, the amount of CO2 in the atmosphere is directly tied to the global temperature. So as we have seen our CO2 go up, we've also seen our global temperature increase. And as atmospheric temperature increases, then at the ocean surface atmosphere interface, the ocean soaks up a lot of that heat. It has capacity to hold a lot of heat, but that doesn't mean that nothing changes. Well, I'm going to get into sea level rise science in a little bit, but I'll give you the prequels because I don't include all my slides. As water warms, it increases in volume. That's called thermal expansion. And as that happens in the world ocean, whoop, you get sea level rise. So just a little bit of heat makes it swell, and then we get a little bit of sea level rise. That's actually the secondary contributor these days. Primary contributor of sea level rise is the melting of land ice on Greenland and Antarctica and other places. But it's at this point contributing about 65% of the sea level rise that we see, or somewhere in the 60s, and it's a big concern and a big point of uncertainty. So ice melt is really cutting edge science these days, and we're keeping close track of it as we go forward. So now let me grab my timing device. Oh, sorry, I'm going way too much into the background. So, well, that's okay. We're about done. So now I'm going to talk just briefly about the work that I've done in Tampa Bay that will lead into talking about the hurricane work. So, and this is mostly just going to summarize kind of sea level rise, part of climate change, but in a local context of working with local governments. So I founded the Tampa Bay Climate Science Advisory Panel in 2014. It was formed with the goal of informing local governments as they plan for a changing climate. We brought together scientists from local academia, county government, regional agencies, state, national. I told you our main working objective. We published in 2015 and updated in 2019. And what the research shows, we went with the NOAA curves from the National Climate Assessment. Like I said, I really like the National Climate Assessment, but we decided as a group, the Climate Science Advisory Panel went through about a 1.5-year process of expert review. Anyway, sorry, that's not the talk I'm giving. Let me go through this quickly. So we have already seen 7.8 inches of sea level rise. And we're able to go to the NOAA Tides and Currents St. Petersburg website, and you can look under water levels. You can see sea level trends. It's a great website with a lot of data. We will say that through our research between the 2015 and 2019 recommendation, we removed the NOAA low because it wasn't a curve, it was a line, and it didn't show any historic, it didn't have any acceleration, just a line based on historic rise. And in 2018, one of our CSAP members, Dr. Gary Mitchum, was a co-author on this report that looked at the 25 years of satellite altimetry and determined that they could see an acceleration signal from the satellite telemetry data, and therefore we no longer could be validated in using a linear projection for the future. Oops, had that slide in there twice. And this is what sea level rise looks like for our future, just to give you a bit of an idea. And now we're very directly tied into our hurricane conversation, because in just a moment here, I'm going to talk about storm surge and how sea level rise, this sea level rise science that I'm showing you right here is very well known. And so what we do know is that in the future, we are going to have sea level rise, and then we'll see the storm surge on top of the sea level rise. So we're going to see an increased storm surge in the future. So what does that mean in terms of how much more we're going to see? Well, these are 3 different projections that we're recommending. But really the NOAA intermediate here would probably be the one that makes the most sense based on the current way that humans are behaving and the amount of CO2 being emitted into our atmosphere. So by around 2050, we would probably be looking at about 1.5 feet of additional rise, and going up to 2100, potentially looking at near 4 feet. But we, of course, are planning on revisiting this data as the National Climate Assessment updates their recommendations every 4 to 5 years. So just to let you know, how do governments use this data? Well, they really need to choose the curve that they're going to look at and choose the time frame they're looking at based on cost of the project, the life expectancy, the location, the risk. You know, you can't have a lot of risk like with this bridge going out to Clearwater Beach there, because you would have public safety issues. But possibly, you know, there's other things that could have a higher degree of risk and take a little more chance. But what does all this that I've been going on about have to do with sea level rise and climate change for hurricane season? Well, first, let's look at this in the context of the 2020 hurricane season. 2020 was a crazy year by all measures, but it was also a crazy year in terms of the hurricane season. So 12 storms hit the US coastline, 5 of which came ashore in Louisiana. 13 hurricanes with 6 major hurricanes. 10 named storms that formed after September, and 10 rapidly intensifying storms, and then the 30 named storms. And we all know we went through the regular alphabet and we went into the Greek alphabet there. We have alpha, beta, gamma, delta. I believe the only other time we did that was back in 2015. Some more facts from NOAA. The NOAA National Hurricane Center has really increased and improved their outreach in recent years. So they're really trying to share what they do and get that out to the public. They do have a webinar series up now that they have a few more weeks of. So if you just Google National Hurricane Center webinar series, you would find that, and Shelly might be able to plug that in the chat as well for you. And then they do record their past webinars and share those on, they share those on their YouTube channel. And so I find that quite enjoyable now with YouTube. If you have a smart TV or a Fire Stick, you can watch educational shows from your couch or your recliner, or as long as you're not watching the screen, you can listen to them while driving if you have to drive in between meetings. So this is just a graphic that the National Hurricane Center made showing the 2020 season, just storm after storm after storm, it seemed. September 14th, we actually had 5 active named storms out at one time. So it just seemed like record breaking after record breaking. But can we tie that active storm to the climate change? Well, we can tie it to 2 things for certain. One is that we had a warmer Gulf of Mexico than we've had in past years. So warmer Gulf of Mexico and Caribbean does mean that we're going to increase our kind of conditions that are available for hurricanes to form. And so that was a direct reason. And then the other reason, and I'm going to make sure I get this right here, is it was a La Nina year. Of course, I misplaced exactly where. Sorry. Yeah, so the La Nina pattern is cool surface waters developed in the equatorial Pacific. So that sounds a little confusing. Let's get to the next slide. I signed it. Okay. Okay. So just to talk for another second about La Nina, but so ironically, cooling the equatorial Pacific makes it easier for tropical storms to form and gain strength in the Atlantic. And that's because the La Nina weakens the vertical shear over the tropical Atlantic. So the vertical wind shear is the change in wind speeds as you go up with altitude, and it can be highly disruptive to storm development. So weak wind shear can make it easier for storm development. So the La Nina season made it more hospitable in the Atlantic for an active hurricane season. We made, I hope, very clear to you that seas are rising. As you can see, this is one of my areas of specialty. So I kind of leaned on it, probably a little too hard, but we do know that the seas are rising. And so as seas rise, our normal storm surge is going to have increased water on top of it. This is from NOAA Tides and Currents showing tropical storm Ada's effect on the St. Petersburg tide gauge station. So you could see the blue line is what was predicted. So even though this was just a tropical storm, I want to emphasize that I guess one takeaway message I would have is that there shouldn't be an expression, just a tropical storm, because we have been seeing storm surge and rain impacts from tropical storms in recent years. So we know storm surges are going to be higher. Okay. Now, previous to 2017, the National Hurricane did not have a separate storm surge forecast. However, especially after Hurricane Katrina and other storms, felt it was really necessary to emphasize the real risk, of a deadly storm surge and the importance of evacuating and being respectful and responsive to that storm surge and getting out. Half of all the deaths associated with landfall tropical cyclones in 50 years have been because of storm surge. So in 2017, the National Hurricane Center created this new product that does show storm surge warning in the darker color and storm surge watch in the lighter color. And I do think that's been a successful pilot study, and I've seen them tweak and change that over the years. So as a reminder, we want to run from water and hide from wind. That's what the emergency managers say, and we want to repeat it. Run from water, hide from wind. If you live on a barrier island in the Florida Keys, somewhere that there is nowhere to run close, then you need to run far to the mainland. This is what Hurricane Michael did to Mexico Beach in 2018. It's not, there's not a reason to take any extra risks. So our second thing that we know to be true in relation to climate change and hurricanes is that we're going to see more rain and more associated inland flooding. As we have those warm waters in the Gulf, it makes it conducive for more water to be soaked up into the atmosphere and to create a stronger, more threatening storm. You could see these rainfall measurements from Hurricane Harvey. I remember when Hurricane Harvey was out in the Gulf of Mexico, a couple days out from making landfall, and the forecast was almost basically a circle. There was very little forward movement, and the forecast was for decreasing speeds. And I just thought, oh man, this is going to be a huge rain event like Florence, and Florence was for the East Coast as well. So let's remember, no such thing as just a tropical storm, because they can become these big rainmakers also that can cause a lot of flooding. And one thing we are learning is that the flooding does not always happen in the areas where the National Flood Insurance Program is requiring people to have flood insurance. So we know that those areas probably have a degree of risk, but then there's other areas that are getting flooded during these major inland storms that weren't, I don't want to say predicted to get flooding, but they weren't required by the NFIP to have federally backed flood insurance. So this is a huge issue. I'm actually working on other projects with the University of Florida, working at collecting better data to assess flood exposure. There's lots of improvements and innovations to be made in the way we do everything as we move forward, because nothing in the future is going to be as it was in the past. So lots of room for innovation. So here's just a graphic to show some of these historic changes in heavy precipitation. This is from the National Climate Assessment. So you could see in the bar graph that the days with heavy precipitation are increasing. And what you see in the graphic image or the map is the percent change, and to whether we're getting more heavy precipitation is in red and less is in blue. So I'm sorry. Yes, more is it. And so we could see the Florida Panhandle specifically has lots of red dots, as well as the Tampa Bay area, showing these increases in episodic heavy storms. This is also something that the Climate Science Advisory Panel that I work with is looking at as our next kind of target for the Tampa Bay region, is to look at the rate of rain. Because when you have a heavy rain, especially if it's coupled with your high tide or a higher tide because of a storm, then you end up with more flooding, street flooding. Number 3 that we know is that increased intensity. We are seeing increased intensity in storms, excuse me. There's a couple things that are kind of close, so I want to get them right. We have more major storms than before. I do find this graphic a little hard to get that out of, even though I know it's true. But in the gray, the lighter gray here, we see the major storms. And then in the darker colors, we have the categories 1 and the categories 2. Of course, we have some of our really significant years, like 2005 goes down as having a lot of major storms compared to other years. One second. So we have a growing proportion of high intensity category 3, 4, and 5 storms. And ocean temperature controls the potential intensity of tropical cyclones, and climate change is likely behind this trend, which is expected to continue. Just to remind us, these are our hurricane scales, and I do really like the graphic imagery. It's good to remind us of the wind effects of hurricanes. So category 1, not generally, mild damage expected. 2 would maybe be some moderate damage. And then I'm trying to remember all the words, but between extreme, severe, disastrous, but you can see how the graphics go. And meteorologists think of hurricanes as generally having kind of a speed limit, a maximum speed that they can reach based on atmospheric conditions. Category 5 there is 157 or higher. I don't know, maybe you've heard some meteorologists in recent years kind of talking about, well, that was a 5+ hurricane, or are we going to have a category 6? I've not heard any talk of introducing a category 6, and there was no max miles per hour in the category 5 here, but we're certainly getting larger, more powerful storms than we could before. So essentially that speed limit for the max intensity of a hurricane is increasing as the water temperatures are increasing. Thank you guys for including your questions in the chat if you have them. I do see that the chat box is got some activity going, and I thank Shelly very much for managing that while I'm chatting. We're going to stick with a format that will have questions at the end. I think I'm, just about 5 or so more minutes before questions. Okay. Rapid intensification. This is one. I mean, if you're a, weather guru like me, and I've lived in Florida since 1999 now, so I've had my share of storms for which I've packed up and moved out of the Florida Keys or gone from St. Pete to Tampa. I did pack up for Irma and moved around a little bit. So I'm here with all the rest of you. And I feel like I'm seeing this rapid intensification of storms happening quicker. But when consulting with my colleagues, so Dr. Wing and David Zierden, we do not have a certain climate signal here. We cannot point and say for sure that climate change is causing the rapid intensification of storms. So it's something that we'll continue to monitor, and that while folks like me who are communicators will continue to make these observations, these science researchers like Dr. Michael Mann and other climatologists will be in the laboratory conducting computer models and real world analyses to determine if this is a climate signal or if it's possibly part of another weather pattern, or possibly part of another weather pattern. So what we do see here, this is the track of Michael, and it was, from 35 miles per hour to 45, and then on the 8th from 75 miles per hour to reaching 160 miles per hour by the time it reached the coast. So that was a very, very short amount of time. I remember I was out of town and just watching how quickly that storm was building, made me truly concerned for all of our friends and families in the Panhandle. Okay, I believe this is error, so we're gonna skip that slide. So are we having more or less hurricanes? Is the frequency changing? Well, there is actually no detectable trend in the global hurricane frequency, and computer modeling studies do have conflicting results. So that is something that we cannot say for certain yet. Changes in what is considered an average Atlantic season, NOAA is simply following standard procedures using the 30-year average and comparing, as I mentioned before. And the numbers are now higher, and some folks say it's because we're entering an active 40-year cycle related to the Atlantic multi-decadal oscillation, but we're not sure that there is a climate change signal there. More research is ongoing, as I mentioned. So just to show you one of these peer review publications that just came out by Michael Mann and colleagues, and this is looking at volcanic forcings and as well as the Atlantic multi-decadal oscillation to try and tease out whether there's a climate change signal looking at the frequency of hurricanes. And the third thing for which climate change signal is uncertain is the longer hurricane seasons. So this year we did, you might have heard from the National Hurricane Center that they started sending out their daily tropical updates on May 15th. So, there's a big question often is that we're simply observing more now, and that's the anomaly, or is it that there are more storms happening? So that research is going to continue to be ongoing. We will say that the last 6 years, the last 6 years have had named storms before June 1st. So there is a trend there. And then I know we've seen several years that have had named storms go past November 30th. 30th. Had to go through the song in my head. Okay, so that is continuing. Now I'm just going to give you a few takeaways from the National Climate Assessment and a summary of our conclusions, and then we'll be open for questions. Okay. So our climate is changing faster than ever before, and it is primarily the results of human activities. That means that we're both the cause and we can also be the solution. So global coordination and collaboration on this issue, and hopefully we can move forward and make some progress internationally, nationally, at the state level, but then also a lot of the best progress is happening at small regional levels like Southeast Florida, Tampa Bay, East Central Florida Planning Council. Got good work going on. And the impacts are already being felt. So I do think for a long time we talked about climate change and sea level rise as a future problem. It is a present and future problem. So, and it is not just an environmental problem, it's a social, environmental, and economic problem. And boy, when hurricanes and climate change collide, the economics are increasingly astronomical. I'm not sure if you've seen, I saw a headline that climate change caused Superstorm Sandy to cost an extra $8 billion over what it would have cost had there not been a climate change signal. Now, I'll have to look at that study and see who published it, but just an interesting headline nonetheless. Americans are getting more resilient. And unfortunately, neither our efforts to mitigate or adapt are going to stop all of the climate change that's kind of like in the pipeline because of our carbon dioxide emissions up to this point. So we do have to continue to prepare for sea level rise, while at the same time, hopefully planning to mitigate our CO2 emissions. So conclusions from the hurricane climate change relationship and what we know to this point. We know that climate change is causing higher storm surge as a result of sea level rise. We know that we're going to see more inland flooding and more rain events associated with hurricanes. We're also going to see more major category 3, 4, and 5 storms. But we cannot tie a direct relationship between climate change and the rapid intensification storms, or between climate change and the number of storms per season, or I should also have added climate change and the length of the storm season. So we have 3 knowns and 3 unknowns. And here's all my social media contact. I hope that you'll follow up with me and find me somewhere else. And at this point, I think I'll turn it over to Shelly for facilitation of questions.
Thank you, Libby. Yes, there's there's an interesting discussion going on in the chat. I don't know that any of them are questions. There's kind of been some conversation happening that maybe people are kind of answering each other's questions. But I don't know if you want to maybe look at them. I mean,
Okay.
kind of starting at 3:25 is when
let me come in the chat.
The conversation kind of started, and then.
Oh yeah, the first thing I see is India and China are the worst polluters in the world, and yeah, I guess I'll just without looking that, I'll chat for a few more briefly just about some local. Well, I do have to remember I'm speaking to folks statewide, so I was starting to think about what we were doing here locally. I'll just say for a long time there was not a lot happening at the state and the national level, and the good thing of that is it spawned a lot of local action with cities and with counties. When Florida left when the US left the Paris Climate Accord, mayors across the country signed commitments to keep up with what they were pledging to do with the Paris Climate Accord anyhow. So city leaders really said, we're going to keep planning for climate change, even if our federal government is not. Now with our new federal government administration, I do think that we're going to see some more money and energy addressing the climate change issue. And also, you know, what we see, what I saw earlier, or I think someone submitted a question before the webinar, a pre-question asking maybe kind of a little bit about infrastructure and should stormwater be looked at or updated? And oh my goodness, yes. So really, I mean, I'm learning all about city and county governments, you know, through working in this role. And I did not have that knowledge before, but basically, as everything does, it comes up for renewal or needs, you know, all infrastructure and buildings need to be, you know, assessed for their viability, for their long-term success under new conditions of sea level rise and climate change. And so as stormwater systems get upgraded over the years, hopefully they'll be put in with a different design than in the past. In the past, we were planning for everything based on gravity, that water would go out the storm drains and go, you know, into the Gulf or into the Bay, and then problem solved. Well, when sea level rise has come up, now we've got water in some of these stormwater outfalls during a good portion of the day. We've got oysters growing in them, making it hard for the water to flow out. I'll say my colleague, Lara Milligan, has got some great stormwater webinars that she's working on. I'm sure Shelly's had some as well. Stormwater is not really a super, what we would call a sexy topic in science, but it is a very important one. So everything going down the drain goes into our water bodies. And in Florida, we really, really care about that water quality. So we want to make sure that our stormwater is taken care of properly, and it's a more challenging issue in the face of climate change.
And Libby, Wayne
yeah.
asked if you talk a little bit about expected changes in ocean currents and impact on food and water. Maybe those are two separate things.
Yeah, I would say those are two separate things. And I would honestly say right now, I'm sorry, but I'm not up on, I'm not primed to answer the question on the changes in ocean currents. I certainly do not want to get that wrong. So it's something that I can find some information and we can send out to folks afterwards. We are expecting, you know, potentially some changes as a result of climate change. And a lot of that has to do with the changing temperatures from the surface ocean temperatures to the deep ocean temperatures as we change them. But I don't want to say more than that. Other than that, my friends did laugh when we saw the movie The Day After Tomorrow in the movie theater like 15 years ago when we were in grad school, because I guess they had the whole ocean circulation model wrong. So I wasn't a physical oceanographer, I was a biological and geological oceanographer. So the physics that I speak from more limited capacity. But system impacts to food and water. Okay, Shelly's got this poll coming up, so please respond to that in your own time. But those responses really do help us. So food and water are definitely going to be impacted by climate change. Right now with food, or let's just say with food, agricultural systems are going to be experiencing the changes in temperature. So increased heat could mean that a crop cannot grow in a place any longer. It also might make an opportunity for that plant to be grown further north than it used to because it's warmer now. Changes in the number of freezes you have overnight and how many hours those freezes last can wreak havoc on things like peaches and other pit fruits that require overnight freezes. When we had our storms this year, like Sally came through the panhandle of Florida, just those storms, that heavy inland rain can really decimate fields of agriculture. So you can lose like entire crops just from one storm event. And some of that did happen, you know, this year and probably caused increases in food that we saw. And water, we are concerned about saltwater intrusion. And that could be from sea level rise, as well as the fact that if we're drawing more water out of surface water like rivers or out of the aquifer, that we might be almost inviting some saltwater intrusion by creating kind of a void there for the water to move in. And it's hard to separate all these things from population pressures. We say we have about 1,000 people a day moving to Florida, and it seems to be growing. So we're going to need innovation again in terms of our food, how we grow our food, how we manage pests. Hopefully we could get better at the amount of food that we throw away and our efficiencies and our food systems and our, what do we call it, supply chains. We learned a lot about supply chains during COVID-19 and where the weaknesses were. And so hopefully we're getting more resilient through our response to COVID-19, like to learning how to respond to storms and work better as communities. One thing I do want to remember to say before I close out, a hurricane presentation is to, of course, know your zone. Be sure to check where you live, check with your local county, your local city, find out everything you can on their hurricane prep websites. You should know well before June 1st whether you're in an evacuation zone or not. You should have a written plan for your house and your family, even if that literally is just writing down like 5 bullets. When we write things down, we're much more likely to see them through. Don't forget to plan for your pets and your relatives, elderly neighbors, check in on them. A lot of different counties have online alert systems that you can sign up for and get all of the alerts. So be prepared, get your supplies, and then when it comes down to it, really do not take chances. I just was on one of those was on a field trial with our drone looking at the flood hazards, and one woman proudly told me she was the only one in the neighborhood to stay during Irma, and I really just do not like hearing those comments, because while someone was fortunate that the storm did not come this way, if that was a different situation, I would have been concerned at the place that this woman had stayed. So
all right,
so,
we are almost out of time.
Yeah.
I thank you for mentioning the poll. If you haven't answered the poll yet, please go ahead and do so. There are a couple other questions that popped up, but if you want to answer them really quick, otherwise we'll wrap up. One is on, I don't know if you have an answer to the response of saltwater intrusion affecting sinkholes.
I do not have a lot of information about sinkholes for that. I think I would go to the State Geologic Society. I think they maintain the sinkhole information, and U.S. Geological Survey has also done a lot of work. So,
and there was also a question about red tide, and I wanted to make sure to mention that the nature knowledge program that we did about a year ago at this time was actually by Dr. Lisa Krimsky, and the whole thing was on red tide. So there's great information there on that.
Yeah, and I don't see that question right off the bat.
It's an increase. Will there be a potential increase in red tide due to climate change?
Okay, and so in a way, yes, with all the associations, but red tide generally, starts offshore with just the perfect Goldilocks biological, physical, geological conditions, chemical conditions, but then it moves onshore with winds and currents, and it does feed on nutrients. So if there were nutrients near shore, then it could feed the red tide. As we kind of already said, climate change is just part of other things that's causing kind of increased, nutrients into, like, just sea level rise could be a part of increased nutrients into the bay based on, the way our storm waters work. So I would say it could potentially exacerbate it, but it's not something that we really have kind of nailed down exactly how red tide and climate change will interact. But yes, I would say yes, we all can agree that it could potentially make it worse. I thank you all very much for your time, and thank you, Shelly. And this will be recorded, and she will have it archived.
Yes, thank you, Libby. This was
if you
great,
email me, I can send further, further points for information.
Yeah, perfect. Yeah, everyone, look out for this video online, and we'll be back next month. We're going to be talking about seagrass bay in the Gulf and how that relates to bay scallops. And then after that month after that, we're going to be looking at wildlife conflict and how you manage that with one of the FWC biologists. And then in August, we have a talk on genetically modified mosquitoes. So lots of different talks coming down the pipeline. So make sure to join again next month. Thanks, Libby.
Thank you. Thank you.